Alright guys, welcome to this page of the notes, and we're going to go ahead and get an opportunity now to practice completing the square with one of these problems where I no longer have a 0 here, I have a y. And remember, the function has to stay y equals, so I'm going to have to do all my work on the same side of the equation. And the way that we're going to put this guy, which is in standard form, check this out, right? It's y equals ax squared plus bx plus c. But I don't want standard form, I want you to put it in vertex form, and we'll do that by completing the square. So here's how it works. Again, I have to check to make sure in order to complete the square, I need my leading coefficient to be a 1, and it is. I'm now going to introduce my parentheses, and they're going to go around my quadratic and my linear term. Now what I'll do in order to complete the square is I will add b squared over 4 inside the parentheses. But to maintain equality, I'll need to subtract that b squared over 4 outside of the parentheses. Well, let's go ahead and figure out what my b squared over 4 is. My b is an 8. 8 squared would be 64, and 64 divided by 4 is going to be 16. Since I added 16 inside the parentheses, I subtract 16 outside the parentheses. And again, just a quick note for you here, right? If I were to combine like terms, plus 16 minus 16, they'd cancel each other out. I'd be left with x squared plus 8x minus 5, which is what I was originally given. That's how I know I've maintained equality. But this is a perfect square trinomial. So let's factor it. Negative 5 minus 16 should be a minus 21. Well, I need an x and an x, right? Because x times x gets me x squared. Both of my numbers need to be positive, and say 16 is a perfect square. Both of those numbers need to be the same number. They need to multiply to 16 and sum to 8, which of course is going to be a plus 4 and a plus 4. And my last step, y equals x plus 4 squared minus 21. And check out what you have now done. You now have y equals a times x plus h squared minus k, where your a is equal to 1. H is equal to 4, and K is equal to a negative 21. And again, we looked back in Chapter 2, Section 7, what each of those does. To the graph, you just simply perform the transformations on the parent function and draw a quick sketch of your quadratic. So here's what we did. We started off with a quadratic that was in standard form, which tells me nothing about what the graph of this quadratic looks like, at least not without quite a bit of work. I'd have to set up a table, I'd have to find my axis of symmetry, I'd have to choose values of x to plug into the function. Once I set up my table, I then have to graph the points, and it's a ton of work. Instead, I complete the square, get it into vertex form, and just by looking at it, I know my a, my h, and my k, and can quickly recognize what the shape of this graph should look like. Awesome. I love it. So let's try another one. This one is going to be a little trickier, and here's the reason why. My leading coefficient is not a 1. So what we'll do in the next video is we'll take a look at how you deal with a leading coefficient that isn't 1 and still get this guy into vertex form. So I'll see you in the next video.